So let's take this equation. Okay, can we do this equation? Z equals 5x cubed minus 3x squared y squared plus 7y to the fifth. Okay, so just for fun again, dz dx equals 15x squared minus 6x y squared. Okay, now we can put a 2 up here. So we say d squared z dx squared. That's the second derivative with respect to x, is going to be 30x minus 12y. How's that? Does that look right? I think that's right. Okay. Or we can say z equals 5x cubed minus 3x squared y squared plus 7y to the fifth, partial of z with respect to y, right, is minus 6x squared y plus 35y to the fourth. Okay, so the second derivative, y squared, would be, now this is a constant, so we're going to get minus 6x squared plus, 140 y cubed. And that's the second derivative. Okay? Remember that this function, this is the slope, but relative to y, right? We have a funky thing going on. And this is how fast dz dy is changing. Yay. Okay. Ooh. Ooh, 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 ooh. 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 All right. Z equals 3x plus 5 times 2x plus 6y. Okay? So I'm going to do partial of z with respect to x. Remember the multiplication rule. So I take derivative of the first part times the second part plus derivative of the second part times the first part. But now I'm only doing this with respect to x. So this thing gives me 3, and I'm going to multiply 3 times 2x plus 6y. And then I'm going to add to that this thing. And now we take the derivative of this with respect to x, and we get 2. Again, we're holding this y constant. Okay? If they take the partial of this with respect to y, partial of this with respect to y, well, there's no y's there. So that's a 0. The derivative of that's 0 because there's no y's. 2x plus 6y, but that whole thing's going to get wiped out. And then we take 3x plus 5 times the partial of that with respect to y, and we get the 6. Fun? 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 It's fun. No? No? No, 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 no? Okay. This is not nearly as much fun as we have with partial derivatives going forward. Okay? Now, your book does a couple of examples, and they spend a lot of time doing them, and I'm not going to spend a lot of time doing them. And the reason I'm not going to spend a lot of time doing them is because of where they are and what they're doing. When you get to A bunch of you are going to take 740 in the fall, and you're going to use the same book, and you're going to do some of these exciting old applications. Okay? But we need to talk about some terms here and do a little bit. So we have what's called a reduced form equation. In a reduced form equation, we have variables as functions only, that's the word only, of the parameters. So, right, in supply and demand, we have these two equations, right? And then we have an equilibrium condition, like that. Okay? There's two variables in this. There's Q's and there's P's. And reduced form equations mean we need to find two equations. One which is got Q's in it, but no P's. And Q is defined by A, B, C, and D. And ones with P's in it, where there's no Q's, and the P is defined only by A, B, C, and D. Okay? So we can set those two equations equal to each other, right? Equal to each other, and say A minus BP equals minus C plus DP. And we've actually done this before. So we can move the C over to this side and say A plus C minus BP equals DP. And then we can move the BP over to that side and say A plus C equals B plus D times P. And then we can divide, right? And get A plus C divided by B plus D equals P. And that's a reduced form equation. Okay? Is that exciting? Yeah, it is. That's one of the two reduced form equations. And again, the point of this, and we've talked about this before, the point of this is now these top two numbers are what? Well, they're the intercepts of the lines, demand curves, and the bottom two numbers are the slopes. So now I can just talk in easy terms about what effect changes in the intercept have on price and what effect changes in the slopes have on the price. So if the slopes are fixed, increases in the intercepts increase the price. If the intercepts are fixed, increases in the slope decrease the price. Okay? So now I can start making legitimate predictions, testable hypotheses, all kinds of statements about how something that affects the intercept or the slope is going to affect the price. Right? So if I put a tax on and that raises the intercept, moves up the intercept for the supply curve, it moves the supply curve up, I'm going to get a higher price. Okay? Life is good. Now it's funkier. We can do the same thing. We can do the same thing by taking these equations, and that's a Q. I know it's a funny looking Q. And solve them for P. Okay? So I take Q minus A equals minus B P. Yes? So Q, I keep thinking about the A. I'm trying to get to the A. Okay? Now you're saying that's not a reduced form. And it's not. But we're only halfway done, right? So Q plus C equals dP. Yes? So Q plus C divided by D equals P. Okay? Now I can put those babies together and say Q minus A over minus B equals Q plus C over D. Yes? And now all I need to do is solve that thing for Q, right? No? Okay. Yes, I need to solve this thing for Q. So we can, let's get rid of the numerators or the denominators. So let's multiply both sides times minus b, and I get q minus a equals minus bq minus bc over d, and then multiply both sides times d, and I get dq minus ad equals, yeah, minus bd minus bcd. Yes? And it's going to work out fine. Think it's going to work out fine. Yeah? Because I'm going to take this and put it over on the other side. Right? Something like that. No? No? Yep. That's a Q. BDQ. BQ. So we're going to multiply that, and we got a minus B times D times Q. You notice that there's a D everywhere. Do you see that? D, 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 and D. So if I divide by D, I get rid of all those D's, and I get Q minus A equals minus BQ minus BC. Yeah, something like that. And I get Q plus BQ equals A minus BC. Q. Okay? No? So I messed that up somewhere. I know I messed that up because I shouldn't have gotten rid of the D. The D should still be there. Because those guys don't have D's in them. What am I thinking? Yes? 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 So this is DQAD. Come back here. Forget what I just did. Because you were supposed to tell me what I did. Yes? So we got DQ plus BQ equals AD minus BC. We've got D plus B times Q equals AD minus BC. And so we get Q equals AD minus BC over B plus D. Okay? So what happens to quantity is more complexical than what happens to price. Right? What happens to quantity is more complex than what happens to price, because those are still the slopes. So we have, just like here, we have the slopes at the bottom, right? Slopes at the bottom, but we have both slopes and intercepts in the numerator. So the denominator's just got the slopes, but the numerator has the slopes and the intercepts. So these are reduced form equations, and now I can do things like take a derivative and see how, no? So we could take the price equation. Yes? Take price because it's easier. That's the price equation.